everyone. Welcome back to my math teaching online. In this video, I will show you the second section of the derivative of the inverse function. Before we get into that, I would like to do something, like related to it a little bit. So let's take a look at what I have on the board now. The first question, as well as the on of this, will be about the evaluate. So we're going to evaluate cos of the inverse of 4/5, sine 4/5. So let's do, so answer number 1. So sine 4/5, I'm going to create a triangle. And let's say I'm going to create it in the, I'm going to create it in the coordinate, okay, in the quadrants. So let's say we have a quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we have sine of the 4/5. So this is the angle, and sine equal opposite, which is 4 here, hypotenuse over hypotenuse. So we make the triangle. We know this is the angle theta, right? So the sine of this angle, and we want to have the cos of this side. So we have to figure out this length, adjacent length, because we're talking about the cos. So this will be equal 5 square minus 4 square, and 5 square is 25 minus 4 square 16, which is square root of 9, which is 3. So this length equal 3. So answer 1, cos of sine minus 1, 4 on the top, 4/5 equal 3/5. That's the answer. That's how you evaluate it, right? So now let's do number 2, which is 10 of sine again, minus 1 on top, minus 2 over square root 5. So let's do this in a quadrant as well. Now you know that this side is negative. So what is the negative side in what quadrant? We have A, S, T, C. A for all of them. S is for sine. Sine will be positive in this quadrant. And obviously T and C, then sine here have to be negative. And we have this in negative value. So we draw the angle in this quadrant and this quadrant. So minus 2 is opposite over hypotenuse. Hypotenuse here is square root 5. Same here. So okay, if we talk about, we talk about this one. So this is square root 5 and minus 2, right? So we will have 2 angles in this quadrant 3 and quadrant 4 for the negative side ratio. So let's figure out what is this. This will be 5 minus square, which is 4, which is this length is minus 1 and this length is 1, right? Square root 5 minus 4 is 1, square root of 1 is 1, right? We know this length is negative, so negative 1, this is positive 1. So we have 2 cases in here, okay? If we have a side negative. So 10 of this side, right, will be equal, 10 equal opposite over adjacent. So opposite is minus 2 over adjacent. So the case 1 will be minus 2 over minus 1, and that will give you positive 2. The other case, right? The other case, same thing like value will be -2 because -2 over 1 is -2. So we have two answers in here for the 10 of this value. So the ratio of 10 of this will be -2. So now let's do number 3. Cos of 7 pi over a. Now this one is easy. We don't have to draw something like this. And why is that? Because we know that the inverse of this is like the ratio of this angle, right? The ratio of cos 7 pi over a, which is we want to find the inverse of this ratio of this angle. And the inverse of the ratio is just the angle itself. So the answer for this question is just 7 pi over 8. That's the answer. Now, what about this? We want to find the ratio of the inverse of this angle. The ratio of this angle of this ratio. So the ratio of the angle of this ratio is just its ratio itself. So the answer is just square root 3. So I hope that you have the clear ideas, the clear concept using on the inverse notation of the trigonometry. And that's why I would like to give you a quick symbol evaluation before we get into the derivative of the inverse. So I hope you understand this video, right? So just remember, this is the inverse of the ratio of the angle, but the inverse of the ratio of the angle is the angle itself. This is the ratio, 10 is the ratio of the inverse of this ratio. So the ratio of this inverse ratio is just the ratio itself. So it's square root 3. I hope you have a clear concept about that, right? Okay, so now, what else we haven't done? We done all of this, okay. So now I would like to get into the derivative. So let's say, want to find derivative. Let's say dy over dx, right? Same thing. Derivative of -10, -1 on top, 3x. So let me show you the other side of the board. So now we get into the derivative of it. Okay. Now in the course, I upload this file for you, which is you will do as many as possible. You can select 1 or 2 questions from this page, right? You don't have to do all, but try to practice as many as you can. It's up to you, right? This is the file upload in your course. You will do the evaluation like this, right? And you will do the some of the question about limit and thing as well, which is you already learned, right? So I hope that you won't have any problem with this. Now, I also upload the solution answer in the file for you. So only do the one I show you the solution. You don't have to do them all, just do the one with the solution provided to you. Now the next page, we're talking about the derivative, and you can read the top here, and you also can do some question here. And again, you don't have to do them all, just do some derivative, which I will show you how to do it here now. And when you do it, when you practice on your own, you can select the one I provide you with the solution, and you can do it. Now, if you like to learn more and more, you can do on them. It doesn't matter. But I believe that usually we have a very limited time, right? For everybody. That's why I just, I don't expect you have to do them on, but it's up to you. If you want to do them on, just go ahead and practice. And if you want to do the one with my solution I provided, so that will help you to save your time a little bit. Okay, so now let's get into the question now. I will talk about the derivative now. Okay, we have the first section. We also do the derivative of the inverse function. That is another style of question, right? And this is another style of it. So I will show you on the style of the question, possibly come up in your own classes when you take the credit with them, or in your school, or from any other teachers, or maybe from the textbook, or maybe from the different teachers or whatever, right? So I'm teaching online, so I select the essential question, major components, I select. Obviously, nobody have time to cover each details of on the question in the textbook. So my job is to research the good one, the right one, the major one, to show you the main idea and show you how to practice the concept. So before I upload any video of my teaching, or I make a lesson plan on my course online, I have to research which question I found is important in the course and try to give you as many ideas as possible, but also restrict for some question I think it's not necessary, or keep repeating, practicing, right? So the part of keep repeating, practicing is your own time management, and your own decision when you want to be expert in math, or you're interested in more and you want to learn more. It's up to you. But the components of my course, I just make sure I cover along the line with the BC British Columbia in math high school curriculum, along the line with the universal language of math, because math have its own universal language, right? Math have its own language and its own accent. I mean, so everybody, you can learn across the globe, from Laos, Thailand, Vietnam to like European. It's the same concept. It's just different language when you express it, but the concept very much universal, right? So I make sure that the course online, I select topic and anything I cover along the line with the high school standard curriculum, and prepare for the university curriculum across the globe. Okay, so let's get back to the lesson. And sorry for my wandering around sometimes. Sometimes I visualize you, like imagine. I have all of you in front of me, smile to me and ask me the question, so I can make my video more lively and more like passionate to serve all of you, my lovely student. Okay, so let me get back to the question now. So we have 10 minus the inverse of 3 of x, right? So we will take derivative of this question. So how do we take derivative of this question? And this is the question 1C in your file upload. Okay, so this is like a y function, right? So now we're going to take y prime. Remember the derivative of the x10, right? dx10 equal, formula is 1 over 1 plus x squared. So now we're going to use the formula here, okay? So y prime will be equal 1 over 1 plus, our x here is stand for the angle. So the whole group here is stand for x, right? Angle x. And our angle x in here is 3x, not 1x, but 3x. And follow the formula, the 3x here have to be square. So this is how we take derivative of the inverse tan of tan's function. Also, we have to apply the chain rule. So this is derivative of the function itself, right? The inverse is this one. We apply the formula. However, we have to do inner derivative. Remember the chain rule, which is we have to time with 3. Derivative of 3x is 3. So the answer for this is 3 on the top, and at the bottom is 1 at 9x squared. So that's the derivative is. That's the answer. Okay. Now let's go to the next question. Let's say if I have a next question is y equal cos of -1 on the top and square root 2x minus 1. Okay, so y prime equal, now the derivative, you have to look in the formula, right? I remember the formula, but if you not remember, you have to look in the formula sheet, which is give you derivative of this is 1, and actually not 1, but minus 1 on of this over 1 minus x squared. That's the formula. So now apply the formula to this function. It will be minus 1 over square root of 1 minus. Now our x here represent this angle, right? But remember this angle is square root of it, right? This is the angle in square root. Now when we square the square root, what happened? The power here cancel with the root here, so they're no longer the radical side gone. So you have 2x minus 1. Now we have to time with the inner derivative. And what is the inner derivative? Now we know that this we can rewrite as 1/2, right? This is the angle, right? Derivative of this angle, right? Derivative of this angle is 1/2, 2x minus 1 on the top minus 1/2. So here, we put this on the top here. So we'll be timed with 1/2, 2x minus 1 minus 1/2. So that's the derivative of the inner angle, right? So now let's simplify this ugly expression. So how do we simplify this? Let me see. First of all, because this is negative power, and I don't like the negative power, right? So I'm going to bring this expression down here, okay? So on the top, still minus 1. Now I'm going to bring this expression down here, and 1 is become a down here. I can put it back in the radical side, right? In a positive way, right? And in radical side. So I have 1/2 in front, and I have 2x minus 1, right? Now this 1 times with this 1, I'm going to simplify this is 1 positive, 1 positive, right? So the positive here, because they're negative here, so this chain become positive. So positive 1 at positive 1 is 2, and minus 2x. Okay, now to make it look even nicer, I'm going to just put the 1 here on top. So here I have minus 1. Down here, I can put this at the division down here too, right, for this 1. And inside, and time with 2 minus 2x. And remember, this in square root, right? They're both in square root. So I'm going to put in the square root, both of them, right? 2x minus 1. So that is our answer. Okay, so that's the derivative of this function. Okay, so I think this time maybe I can let you do it on your own to see if we have anything come up with. But I'm going to show you maybe one more, just in case. So I'm going to steal this ball, a part of this ball again. All right, I'm going to stealing it. So let's do just one more question. I'm going to choose the weird question. So I'm going to do one more, which is 3. We say try to find derivative of sine minus 1 on top of x over cos minus 1 of x. Okay, so how do we take derivative of this function? Remember the quotient rule. Keep the denominator cos minus 1 of x on top, the same, right? Keep this one, derivative of this one. So keep this one, derivative of this one. And derivative of this one is using the formula 1 over square root of 1 minus x squared. Right? And the angle, our angle is x, so the same. We don't have to change anything, right? Minus, now keep this one, sine minus 1 of x, keep this one, derivative of this one. Derivative of this one is negative and the same thing, right? On of this over cos minus 1x on of this square. That's the formula for the quotient rule. So now y prime will be equal, let's simplify a little bit, okay? I'm going to take out the common denominator of this one and this one, right? And actually, because we have a negative times with the negative, so I'm going to change this become positive and positive as well, just to make it easy, right? We have negative times negative, so positive. Okay, so now I'm going to take this out as a common factor, 1 minus x squared. Inside, I have cos minus 1 of x plus sine minus 1 on top of x. All of them over cos minus 1 of x all of this square. Okay, so now let's simplify a little bit to make it look pretty, but that is how you done, right? I'm going to just join this one with this part, right? So we have on the top to make it nice, plus sine minus 1x, all of this over square root of 1 minus x squared, times with cos minus 1 of x all of this square. So that's we done. So that's the third question, right? You can see it now, right? So it's the question, and we go on through all of this, okay? So I think that I'm going to end the chapter 6, the derivative trigonometric function, by this video. I have provided to you the first application of, I think there are 2 video application of derivative trigonometric function. So I think that enough for letting you explore more about our topics and do it. If you register in my course, you can practice the exercise. And if you have any question, you can email me, or maybe like make an office hour on the Zoom online for a couple of times. I don't know. It depends on how much time I can arrange, right? But I hope you enjoy my online course. It's cover a lot of important components in the curriculum, and it condensed for you. Instead of 1 year, now it's like 3 months or six months when you learn it on your own, right? So I hope you enjoy it, and thank you for watching. Give me a thumb. You like it? You like it? Hit like and subscribe to my teaching channel online. And thank you for watching. I will see you in the next video. We start get into the chapter 7, which is the last chapter of our course online, Introduction to Calculus course, which is the derivative of logarithmic function. And don't forget, if you like the first section of my first course online I developed on my own, then you probably will be interested in the second half of it, which is antiderivative integration of the total combination of Introduction to Calculus. After you went through with my course, it gives you so much knowledge and confidence when you get into the first calculus course in the university. And learning is a rehearsal and review, so it never wastes your time or waste anything. Whatever your knowledge you store in your mind, right? Everything can be gone, money, reputation, materials, like if you have a wind, disaster, natural disaster, everything can be gone. But whatever as long as you're alive, like whatever in your mind is there for you, is the treasure, it's the storage in your mind. It helps you to build your skill, your own skill, and you can make a meaningful future and earning living, right? Now, there's a proverb like give you a fish. I think it's an English proverb or something. Give you a fish is like feeding you and your family the whole day or the whole week, but teaching you how to fish, give you a lifetime of, on the lifetime of your life of meals, like you can feed your own yourself and feed your whole family for the rest of your life. I don't remember the proverb, but I remember the scenario, something like that, right? And we all learn from that. Anyway, so as I standing here and show you whatever I learned from my teacher in the past, I always respect and appreciate my previous teachers has teach me how to fish. Not giving me a fish, but teach me how to fish. Anyway, I hope you enjoy my video. Bye for now, and sometimes forgive me my talkative. Bye for now.